Good day, learners. Today we are going to continue our solutions of May-June 2020, paper 11. And this one is number 7. So here in our figure here we have this rectangle 8 centimeters by 3 centimeters into 1, 2, 3, 4, 5 rectangles. We have to work out the perimeter of our figure. So here class, let us find first the perimeter of one of the figures here. Anyway, they are all the same, they are all equal. So the perimeter here of this figure is we have 2 times 8 because we have 8 here also. 2 times 8 plus 2 times 3 also here. So the perimeter of our rectangle is equal to 16 plus 2 times 3 is 6. So the perimeter of our rectangle, one rectangle only, is 22 centimeters. The problem here class is if we are going to connect them, this one will not be included, this portion here, 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 and there. Okay, so we need to subtract that one. We can have the length of this one, which is also the same as this. 1, 2, 3, 4, 5, 6, 7, 8. Now, how can we determine the length of this small portion here? We know this one is 8, so this one is 8, and this one is 3. So we have 8 minus 3 is 5, and then we divide it into 2, so we have 2.5 and 2.5. So we have 2.5, 1, 2, 3, 4, 5, 6, 7, 8, 2.5. Now this one is also 3, this one is 3, okay, and this one is 3, 3, 3, 3, and this one is 8, 8, 8. We can determine the perimeter of this figure by multiplying 8 by how many 8s and 3 by how many 3s. Then we add them and we have the perimeter. But let's have another method of solving this one. Okay, that is the first method if you want. Now we can have the second method in which we have this one is standing, the other one is lying here, 8 here, but here is 3. So for this one, how many figures do you have here? The standing rectangle. So we have 1, this 1, 2, and 3. So we have 3 of this. Now what is the perimeter of this one? It's 22. So the perimeter, the total perimeter of this figure here is 22. The perimeter of one only, but we have 1, 2, and 3. So we multiply it by 3. So the perimeter of this rectangle, the standing rectangle, is 66 centimeters. But the standing rectangles, we have to subtract the side, the portion of one side or two sides here. So we are going to subtract how many 3's? Because this one is 3, 3, 3, and 3. So we are going to subtract this side here on the first standing rectangle here. 3 plus here is 2, 6, 9, and here is only 1, 3. So we have 12. So we are going to subtract minus 12 centimeter here. So we have the perimeter of the standing rectangle. So 6 minus 2 is 4. 6 minus 1 is 5. So we have 54 centimeters. What about the two lying rectangle on its side? So here we have 2. So let us get the perimeter of the 2 because we have 1 and 2. So the perimeter is 22 of one rectangle. So we have 22 times we have only 2. So times 2 is equal to 44 centimeters. But because of this, also we are going to subtract how many? 1 here, this one, and then on the other side is this one also and that one. So how many, what is the measure of that one? The total length that we are going to subtract. We have 3, 6, and it's also 12. So we are going to subtract 12 here, centimeters. So 4 minus 2 is 2, and 4 minus 1 is 32. So we have 32 centimeters. So the total perimeter, or the perimeter of this figure, is we're just going to add the 54 and the 32. So the total perimeter is equal to 54 plus the 32. So our perimeter here is equal to 86 centimeters. Number 8, we'll find the highest odd number. That is a factor of 60 and a factor of 90. This is the highest common factor, but the highest common factor must be an odd number. So if we have this one, we can have the complete factoring if we want, and the complete factoring of 90. For 60, example is 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, 7, no, 8, no, 9, no, 10 times 6, we have already that one. Okay. And for the factors of 90, we can have 1 times 90, 2 times 45. Okay. But it's better if you are going to write that one, these two numbers into its prime factored form. Do you know how to get the prime factored form? The PFF? Okay, let's do it. So for 60, like 60 here, and we have the inverted symbol of division, or the manual division. So we have 60, we start from the prime numbers 2. After 2, we cannot use the 2 anymore. Then we have 3, 5, 7, and then 11, 13. So let's start with 2 because we know that 60 is divisible by 2. So when we divide this by 2, we write our 2 here. It's a prime factor. So 60 divided by 2, so that is 30. Now 30 is still divisible by 2, so we divide it by 2. So we have 30 divided by 2 is 15. Okay, let's say 15. Now 15 cannot divide this one by 2 anymore, but we can divide it by 3. So we divide this by 3, and then we have 15 divided by 3 is 5. So we have the prime factored form of 2 squared times 3 times 5, and that is 60. Now let's have the 90. For 90, we will write our 90 the same as this. So we have 90, then we start again with 2. So we divide this by 2 here, and 90 divided by 2 is 45. Now 45 is not divisible by 2, but we can divide it by 3. So we divide this by 3. So 45 divided by 3 is 15. Okay? And 15 can still be divided by 3. So we divide it by 3. And then we have 15 divided by 3 is 5. So the prime factored form of 90 is 2 times 3 squared times 5. Okay, let's have the common to 60 and 90, the numbers. So we have here the 2 and the 2. Okay. The 2 here, we don't have the 2 anymore there. Okay. 3, yes, we have the 3 here and the 3 here. Okay. The 5 here and the 5 here. Okay. So if we are going to find the highest common factor of 60 and 90 without saying that is even or odd, 2 times 3 is 6 times 5 is 30. That is the highest common factor. Here is also 2 times 3, 6 times 5 is 30. That's the highest common factor. But in our problem, they are saying we will get only the odd highest common factor. So the odd highest common factor is we cannot include the 2 anymore here and the 2 here because they are even. And then when we multiply them, it will give us an even product. So here we have only 2. 3 and 5. Here is 3 and 5. And when we multiply 3 and 5, that will give us common odd factor is 15. So this is our answer for number 8. Number 9, we have our graph here. We have point P and point Q. For letter A, find PQ. You see the arrow here. It's from P to Q because of the arrow. Now, we are going to find the column vector of PQ. So, let's have first the coordinates of P. While the coordinates of P, that is 2, -1. And for Q, it's -3 and 2. Okay. How do you find the column vector? The column vector is written in the vertical form. The number on the higher part is the X and the lower part is the Y. If our X is positive, it means that we are going to the right. If that is negative, then we go first to the left. And then if the Y is positive, we go up. If the Y here is negative, then we go down. Because if we have the origin here, it's just like this, in which if we go to the right, all the numbers to the right are positive and all the numbers to the left are negative. All the numbers going up, they are all positive, and the numbers going down, they are negative. It's like that. So, vector, column vector PQ means we are going to start from P. Okay? And we go first horizontal, not vertical. So, horizontal, so we have 1, 2, 3, 4, 5, and we go to the left. We are moving to the left. Therefore, this one is -5. 1, 2, 3, 4, 5. Then we are going up. It means that this one will be positive. So, we have 1, 2, and 3. So, this one is our column vector for vector PQ. -5 and 3. For letter B, it's 3 PQ. It means 3 times of the column vector PQ. So, we'll just multiply -5 and 3 by 3. So, here, as if we are writing the 3 here, 3 PQ. So, 3 times -5 is -15 here. And 3 times 3 is 9. So, this is the column vector of the 3 PQ. What if our column vector is, this one is not included in your past paper, but I'm going to write here. What if we have QP? Okay, we have an arrow here. So, what is the column vector of QP? So it means that we are going to start from Q and we are going to P. So from Q, here, we go first either right or left. So we go to the right. So I have 1, 2, 3, 4, and 5. So this one is 5. And then from here we go down 1, 2, and 3 because we are going down. So it is -3. Okay. When we have the opposite PQ is -5, 3. When we have the opposite QP, vector QP, we multiply this by a negative number, negative. So negative times negative, so you see it's positive now. Negative times positive 3 is -3. It means that this vector is opposite the direction of this vector, but they are of the same magnitude. What if we have this one? The measure of, you see the symbol of absolute value, and we have PQ. Here, our QP is the same. So, and then we have -5 and 3. So what is PQ? The measure of PQ when the column vector is -5, 3. So this is only Pythagorean theorem, because here we will have a triangle. Can you see the triangle here from Q, here, and here? So if we are going to draw that one here, we are going to find the distance PQ, that is the measure of absolute value of PQ, then we will apply Pythagorean theorem. And this one is our PQ, or let us say this one is your X. So in Pythagorean theorem, we have x squared, which is the hypotenuse, because this one is a right angle, is equal to 5 squared plus 3 squared. Or you can have the 3 squared here and the 5 squared here. And then after that, we have the 25 here and the 9 here. 3 times 3, not 3 times 2. This is 5 times 5, not 5 times 2. So we have x squared is equal to 34 and x is equal to square root of 34. So PQ here, absolute value, is 34 square root, the positive root.